Welcome to Unit 8, Lesson 2, Transformations of Exponential Functions. In this lesson, we're going to look at what happens when we move the graph around using those values that we're becoming really familiar with, a, b, h, and k. So at the top, you have your base function, your general function. It's f of x, that's our y, is equal to a. A still does the stretches vertically, times c. C is our base in this unit. So it could be 2 to the power of whatever that looks like. B, which is still our horizontal stretch. X minus h. H is still our horizontal translation, left or right. And then plus k, which is our vertical translation, up or down. So there's an example here to show you what it looks like. We are using the base function. There's a different base function in each question, but just look for the one that's going through that point 0, 1. So in this example, we're using y is equal to 3x. So if we're looking at what does a do? Now don't forget, you can still use those mapping points to give you a really clear picture of what's happening to your transform function. And that will make it really easy to create your mapping points to see where to move your graph. So in this part of the example, x values don't change, and then all our y values we're multiplying by the value of a. So if we look at the graph of y equals 4 times 3 to the power of x, we would have mapping points of x for y. And then in the other example, y is equal to negative 2 times 3 to the power of x. We would have our x values, and then negative 2 times our y values. So notice that it's done that reflection over the x-axis because of that negative 2. It's going off in that other direction. The b still does the same job. It's making our graph skinnier or fatter. And you still figure it out the exact same way. So whatever b value is given, you're dividing the x's by it. So to work with the b value, you're going x divided by b, y's for your mapping points. In this example, we're using the base function y is equal to 2 to the power of x. So here, y is equal to 2 to the negative 0.5x. You're going to have your mapping points x over 0.5, y. And notice that the negative flips it over the y-axis. And then in this example here, 2 to the power of 3 times x, you're going to have your mapping points x over 3, y. The vertical translation is really, really simple. You're just moving the graph up or down. Nothing's happening to the shape of the graph. So just notice that those dotted lines represent the asymptote, and that your asymptote is changing here. So wherever the value of the k is, that becomes your new horizontal asymptote. And then the same thing with the h, the horizontal translation f, left or right. It's just moving the graph to one side or the other. So you're going to have x plus h, and it will just move the graph left or right. So not too much has changed. You can still use those mapping points to move your graph around, and I highly recommend doing that to just see what is the pattern you're working with and to really simplify it, because you can just create a quick table of values with like 3 or 4 points and then just draw the shape of your graph. So we just have 2 quick examples here. One on the top, consider the base function y is equal to 3 to the power of x. So we're starting with that graph, and I've given you the base mapping points for this graph and then showed what are the coordinates of the new changes. So your mapping points, we're going x plus 4 because you have a minus 4 here for your h value, and then 2 times the y's because your a is 2. So really simple and straightforward. Just apply those changes to your x and y coordinates to get your new graph. The next example, it looks really scary, but just look for your a, b, h, and k and write out your mapping points. And then once you have that, you will be able to do a really good job of that. So we have negative 1/2 times 3 3, this is our c, our base function, to the power of 1 over 5x minus 5. So here is your k value. There's no h value here. There's no shift, but there is a b value, which is 5, or 1 over 5. So of course, 1 divided by 1 over 5 becomes the flip and multiply. So this is your b. And here is your a value, negative 1/2. I didn't write the 1 here because we don't need to, but it's y divided by negative 2. So once you have your base points, and then you can do your mapping points, all x's times 5, all y's divided by negative 2, and then down 5. Don't forget to do your a and b values to your function before you do your moving around your h and k. And one last example, describe the transformations to obtain the graph of y equals 4 to the power of negative 2 times x plus 5 minus 3 from the graph of y equals 4 to the power of x. So our base function is y equals 4 to the power of x. Our b value is negative 2. Our h is, it shows plus 5 here. So we know that this is x minus 5, x minus negative 5 would give us negative 5 of an h value. And then we're moving the graph down 3. So we're going to flip it over the y because of that negative value. It'll be a reflection. Divide your x's by 2. You can also just divide all your x's by negative 2, but this is what's happening to the graph. And then we're going to shift left 5 and down 3. Now the domain is not affected by this. It's still going to go negative infinity to positive infinity, but notice that your range changes. The horizontal asymptote is no longer at y is greater than 0. It's now at y is greater than negative 3. And that's described in example B there. Beyond this, you have some practice questions to help you practice this concept.